4.3.11 construct algorithms using the access methods of a collection. So when we see access methods of a collection, we know that they must be talking about linked list and array list, the two pre-made classes we can use in Java, not just arrays. Theoretically, I suppose you could say that there are access methods, as it were, or access ways for arrays. So here are our arrays that we looked at last time. How do you access element number 012? Well, you just do it with the brackets and you put the element number there. But it's not through a method. So really what they're getting at here is collections, is these two things that we can use which have methods that look something like that. The first thing will be the ArrayList class, and the second will be the linked list class. And I might as well put a class of Java. Pre-made for us. So let's do the ArrayList first. Let's call our ArrayList A list. How about ARR list? Our array list called rlist is assigned new array list. Do we need to import that? Yep. Already got it there. Oh, I just need a semicolon. If I didn't have that there from my dry run before, then I would need to import it. Same thing with a linked list. Put it down here, linked list. We'll say LL. Assign new linked list. Again, we need to import that. But we'll push that down and deal with that later. Maybe now's a good time, though, to look at the difference between the structure of an array list, and a linked list, and even when to use it. So I'm all set up. Array. An array is a bunch of similar elements in memory side by side. So the 0th, 1st, 2nd, 3rd, 4th of ints or strings or something like that. An array list is similar. It's also like a container that has a set number of elements, except for the set part. Because, unlike an array, you can change the size of an array list. Or indeed you can, not just change by making it smaller, but making it larger. In other words, you can add and remove elements to an array list. You cannot add and remove elements to an array. When you have an array that is 5 elements or 3 elements, it is that way forever. You cannot change it. It is static in that way. Whereas, that's the great thing about ArrayList. It seems like it's an array, but actually, in the memory of a computer, it's more like a list. And so you can add to it and remove from it, which is great. The linked list, meantime, is a true linked list, which we'll look in depth at later, where the elements are not side by side. They don't even seem to be side by side. The way that it's implemented, they are pointing to each other scattered through memory. So that one points to that one, that points to that, and so on, and so on. So they're able to find each other, not because they're beside each other in memory, but because they know the address of the next element in the link. And they can grow. They are dynamic, just like ArrayList. And so they can grow, and they can also shrink. So when do you use each? Quickly, you use an array when you have a definite number of elements, and that number of elements will not change. You use an array list when you have an indefinite number of elements. In other words, it may grow, it may shrink, but you generally are working with the whole thing. You're looping through the whole thing just like you would loop through an array. And with a linked list, it's when you don't have a definite number of elements. They can grow and shrink, but you're really not worried about the ones in the middle. you're dealing with the ends, like a queue at a cafeteria. A line at a cafeteria, the people in the middle just stand there. It's the people at the front that are served. Or a stack of papers. If you have a stack of papers, well, you're not worried about the ones in the middle, you deal with the paper at the top. So with linked lists, we're accessing and dealing with either one end or the other. And lots more on that later, but here's the programming. First array list. Now let's decide what kind of array list we're going to make. You can declare an array list this way, but then you'll have to convert things into the type that you want later on, so it's much better to do it from the beginning. Let's work with doubles. And you might be inclined to type in that for double, a real number, but it's not going to work because what it's looking for here is actually a class, and double with a capital D in this case. And you also put this left and right chevron there as well. Let's take a good look at that. That's the first time you would have seen it. This says array list of double type called rlist is assigned new array list. Let's add a bunch of stuff, a bunch of doubles. Let's take a look. Take a look at the things you've got to work with. And add is what we want for this straightforward example. And there's a double. And here are a few more. So let's see what we've got. It's like an array, so we can loop through it. Only it's not going to be like an array where we go less than the array dot length attribute. It's actually a method called size. It gives us the size to loop up until. And we will sout, and get is the method we use. Take a look. Get. And it takes in the index just like if we were working with an array where we would put the index between the open and closed bracket, but here it's actually a method get. So did it go there? No, get. And I. So let's run it. And see that we've got everything there. So now for the neat thing about array list, we can add and remove. Remember, if this were an array and we had put 4 things in it, it would be stuck at 4 things, but this is not. So actually, let's remove before we do anything else. Let's remove the second 0, 1, 2. So dot. So we want to remove. And remove, what do we say, 2. So we just removed it. Now we can copy and paste this code to see that it is indeed removed. And it's always better to put a line between the 2 output loops. So there you can see that we have achieved what we expected. The 0, 1, 2, the second is gone. The 777, 888 is now removed. And that's basically it. We could continue to add, wouldn't hurt. Let's just do that one more time. So AR. And some other numbers. Just to prove the point. And show it. So now we should have that was removed, that, and then all those when we run it. And there you go. So that's really all you need with array list. Arrays that can grow and shrink. So now we move on to linked list. I'll put it up at the top, and I'll comment out this. Same idea with with linked list, that we should give it a type, the type that we know we're going to work with. So let's work with string. And that's going to help actually working with string, because we can see what was the first and so on, second, third to have been added. So ll dot add, it is add, same thing, add a string, and right. So we could do something so that we could loop through all of this, but it really makes no sense, because again, don't want to beat a dead horse, but remember that when we're working with linked lists, we're not looping through them all. We're not doing something to all of them. We're working with one end or the other, usually. So let's try removing the first. So here we go. What do we got? Remove, bunch of removes, remove first. That would be like a queue where you're dealing with the front one. And actually, why don't we print that out too? All right, so there it is. Printed out, used somehow, but now gone, discarded. It no longer exists. We've removed it. So if we were actually to print out remove first again, what we're going to see is actually that. 1 second. Now, if it's being treated as a queue, I'm jumping a little bit ahead here, but what we would probably want to do is just keep on adding on the end. So let's see if that works just by going add. I'm going to throw in something else here. And I'm going to go now remove first, remove first, remove first, remove first. So 4 remove firsts should empty this list. If I'm correct, right? Because I've already moved that one. And then we've got 1, 2, 3, 4. So we're removing first 4 times. In the diagram, it would be, we've already removed that one. And 1, 2, 3, 4. So the diagram would actually be like this. There would be 4 remaining. This would be second, third, fourth, and then the thing that I added. So remove, 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 remove should empty the list. Did we go too far? Well, there, you saw the error that happens when you go too far. So, oh yeah, because I removed first twice there. My mistake. But think about it. 1, 2, 3, 4, 5 added. 1, 2, 3, 4, 5, 6 removed. And I didn't do that on purpose. So you might as well see what happens when you try to access an element of an array or an array list that doesn't exist. It tells you it doesn't exist. No such element exception. So take that away, and I'm going to empty the list now properly. And there you go. When we get into queues and stacks, we'll need to come back to this and learn a little bit more, but that's basically it. With a linked list, you're dealing at one end, and we were dealing at the beginning. We were adding, and then removing. C'est ça. Non plus.